12.4, analyzing relationships with angles and segment lengths within and around a circle. Today's objectives: find lengths of segments associated with circles, and secondly, find measures of angles and arcs formed by chords, secants, and tangents. Let's take care of the first one first: lengths of segments associated with circles. Our first few questions resemble the chords intersecting inside a circle. As the theorem states, if two chords intersect inside a circle, the product of the lengths of the segments of one chord equals the product of the length of segments of the other chord. Let's demonstrate that with a few examples. Example number 1. Again, when we have chords intersecting inside the circle, we just have to find the product of the segments within the segments and set them equal to each other, like this. 8 times 7 is going to equal 14 times x. Do the math and solve. Our answer is going to be 4. Similar question. Let me start it out. You finish it up. 18x is going to equal what? You guessed it. You said it. Whatever 3 times 9 is, 18x equals 27. 27 over 18 is going to simplify to 3 over 2. Done. But what if they're not two chords? What if they're not segments that are defined or divided inside a circle? What if they are like what we have identified in green here? Take a moment to pause and observe the relationship. I like to call this one the whole times outside method. Notice the secant that includes A and B. I first take A plus B, that's the whole thing, and then I take it times B, that's just the part outside. Notice I do the same thing with the other secant that includes C and D. I do C plus D, the whole thing, and then times the outside portion, which is D. Let's put this one into practice. For the red segment, the whole thing is going to be 20 plus 9, or 29. The outside portion, outside the circle, is just the 9. In setting up the rest of the problem, the whole thing for the green side is 10 plus x. The outside portion is 10. Now, to solve this one, you're going to distribute the right side and solve. Collecting like terms, subtracting 100 from both sides, we would find 10x to equal 171. And if you divide both sides by 10, you'll get 17.1. As always, follow directions onto whether they want fractions or decimals in their final answer. Now your chance. Can you set this one up? Well, if I'm looking at this side, the whole thing is going to be 32 times the outside is the 12. For the other side, we have the outside, the whole thing, being 8 plus x, and the outside being 8. I'm not going to continue to solve this one, but again, we would follow the same exact process in solving this one. This particular question tends to throw people off a little bit, but let's do it the same exact way. Let's start talking about this one. The whole thing, 9 plus 7, it would be 16, times the outside portion is 7. If I look at the other portion, looks like the whole thing is x. And it looks like the outside part is also x. So in this question, we're just getting x squared is equal to 112. Next and last step, take the square root of both sides and you will have your answer. Quick summary. Again, when the intersection is inside, find the product of the two pieces. If the intersection is on the outside, well, we got to take the whole times the outside. And our final objective, let's talk about the angles now associated with angles and arcs formed by chords, secants, and tangents. This first question, this is not technically an inscribed angle, but it really follows the same exact rules. The vertex is on the circle itself. The intercepted arc that we're looking at ends up being 148. And it's not a central angle. It's on the circle itself. So just divide it by 2. 148 divided by 2 is going to be 74. That angle, x, is equal to 74 degrees. Cut it in half. When finding angles that are inside the circle created by 2 chords, it's not going to be as small as an inscribed angle when you cut it in half. But it's not going to be as big as the central angle to be just exactly the same. Seems like a good compromise might be to find the average. If I want to find this angle of x, first of all, note vertical angles are congruent, so the x is in the same exact place. But what I'm going to do is find the average of those 2 arcs. That means I'm going to take 110 plus 30 and divide it by 2. Angle x ends up equaling 70 degrees. When inside, average the intercepted arcs. What if the intersection is outside the circle, in this case made with a tangent line and a secant, but it could be 2 secant lines for that matter as well? Again, we intercept 2 arcs. But in this case, when the intersection is outside the circle, when the intersection is not within the circle, we're not going to add them and divide by 2. Instead, you will find ourselves subtracting and dividing by 2. In this case, then, we're going to have 110 minus 30, and we're going to divide that by 2 to find our x. In this case, x is going to equal 40 degrees. When the intersection is inside the circle, add them up, divide by 2. And when it's outside the circle, subtract and divide by 2. This concludes our overview of 12.4. This is a big section, lots of things going on, and a few things that we need to kind of memorize. Take it in. Let's give it a shot.